7.2, the ambiguous case of the law of sines. So in 7.1, we talked about different cases for solving oblique triangles. So I'm just going to pull this back up real quick. So in 7.1, we talked about case 1, where there's one side and two angles are known. And the side and angles are known as either side angle angle or angle side angle. For case 2, which is what we're going to talk about in section 7.2, is two sides and one angle, which does not include the angle between the two sides. Okay, so this is side-side angle. This is a case that may lead to more than one triangle. So case 2, this is the ambiguous case of the law of sines. So first, let's talk about different types of triangles and then their possible number of outcomes. So for our sketch 1, we have that angle A is an acute angle. Okay, so from this we can see that obviously H is smaller than B because this is a right triangle on the inside and B has to be the largest. Okay, and then side A is smaller than H. In this case, if we take sine of angle B, we are going to get a value that is greater than 1. Recall the range for sine. Okay, so the range for sine is between -1 and 1. So if sine of B is greater than 1, this is not possible. Okay, so the possible number of triangles for this case would be 0. For the next sketch, we have angle A is an acute angle, and we have A equals H, and then we have H is less than B, or A is less than B. Okay, so you can see from here that this is a right triangle. So if we took sine of B, it would be equal to 1. Okay, so this is one possible triangle, which is the right triangle. Our third case here, A is still an acute triangle, an acute angle. Okay, in this case, B, sine of B is going to be between 0 and 1. Okay, and then we can see that A is greater than or equal to B. Okay, this type of triangle is going to lead to one possible triangle. Okay, our next triangle, angle A is still an acute. Okay, so in this case we have that sine of B1 is in between 1 and 0, and A is greater than H but less than B. Okay, we also can note that A plus B2 is less than 180 degrees here. Okay, this case is going to result in two triangles. Okay, and we'll work more with these so you'll understand what it actually means to have two triangles. Okay, our next case, angle A is obtuse. Okay, so if angle A is obtuse, and sine of B, if sine of B is greater than or equal to 1, then that tells us that A is less than or equal to B. Okay, which is not possible, because if A is obtuse, then it must be the largest angle in a triangle, which means that its side must also be the largest side in the triangle. Okay, so this is going to give me 0 triangles. This is not possible. Note again that sine B cannot be greater than 1. And let me note here, I use parentheses. These should be brackets. Okay, because -1 and 1 are included in the range. Alright, and then our last sketch, we have angle A is an obtuse angle. Okay, and in this case, we would get sine of B is in between 1 and 0. Okay, so that satisfies the range. And we would have A is greater than B, which is also true, because if A is obtuse, then it is the largest angle in the triangle, which means its side corresponding to angle A should also be the largest. So in this case, we would get one triangle. So in these cases, if you get sine of an angle greater than 1, then that triangle is not possible. If you get sine of an angle equal to 1, then that is a right triangle. Okay, our two cases, or other two cases that are going to actually give us angles, triangles. So you either have a right triangle or you have no triangles if the sine is greater than 1. Or you could have one triangle, one oblique triangle that's acute, or one oblique triangle that's obtuse. Or the ambiguous case is if we have two triangles that are possible. So applying the law of sines. For any angle theta of a triangle, sine theta must be between 0 and 1. Okay, so we've talked about this already. If sine theta equals 1, then theta equals 90 degrees, and the triangle is a right triangle. The next part of applying the law of sines is that sine theta is equal to sine of 180 degrees minus theta. So this means that supplementary angles have the same sine value. Okay, so this part number 2 is going to be very important in determining whether we have one or two triangles. The third case is that the smallest angle is opposite the shortest side. The largest angle is opposite the longest side. And then the middle valued angle is opposite the intermediate side. And this is assuming that the triangle sides are all of different lengths. Okay. So all three of these must apply for you to have a triangle. Alright, so we have example 1. Solve triangle ABC if side A is 17.9 centimeters and side C is 13.2 centimeters, and then angle C is 75 degrees and 30 minutes. Okay, so here I have the triangle drawn out. So I just want you to see that this is side angle. Okay, side angle. So notice that the angle that we are given is not included in between the two sides. Alright, so we have a few unknowns here. So first let's solve for angle A. Okay, so we can use the law of sines. So we know side C and we know side A. So that's why I'm solving for angle A. So we have C over sine C equals A over sine A. So we know side C is 13.2, and then sine of 75 degrees, 30 minutes, equals 17.9 over sine of angle A. Okay, so this gives me 13.2 times sine A equals 17.9 times sine of 75 degrees in 30 minutes. So sine A equals 17.9 times sine of 75 degrees in 30 minutes over 13.2. Just a second, let me grab my calculator. Alright, so we are in degrees, so I want to make sure my calculator is in degrees. Okay, so we have 17.9 times sine of 75 degrees, 30 minutes, And then we're going to divide that by 13.2. Okay. So we are trying to solve for angle A. So we are going to take the inverse. So we have A equals sine inverse of what we just found. Okay. So sine inverse of all of this, if we brought it down, so that'd be sine inverse of 1.3128668676. Okay. So if I take sine inverse, and I'm going to just use the answer that we had, so second in answer, I get a domain error. Okay, why do I get a domain error? So that comes from the fact that sine inverse's domain is between -1 and 1, and the value that we have is greater than 1. Okay, so because this is greater than 1, so because sine of A is greater than 1, no such triangle exists. Okay, so this one is not possible. Sine of any angle cannot be greater than 1. Okay, example 2. Solve for triangle ABC if angle A is 61.4 degrees, side A is 35.5 centimeters, and side B is 39.2 centimeters. Okay, so I'm going to draw my triangle. So I have A, B, and C. Okay, so we know A is 61.4 degrees. We know that side A is 35.5 centimeters, and we know that side B is 39.2 centimeters. Okay, so notice again that this is side-side angle. Alright, so we want to find B. Okay, we're finding B because we know A, we know side A and angle A, and we know side B. So we can find B using the law of sine. So we have A over sine A equals B over sine B. Okay, so this is going to give me 35.5 over sine of 61.4 degrees equals 39.2 over sine of B. Okay, so after I multiply this out, I have 35.5 times sine B equals 39.2 sine of 61.4 degrees. So sine B is equal to 39.2 times sine of 61.4 degrees over 35.5. Okay, so then I take sine inverse. So you can solve for this, or you can do B equals sine inverse and then bring all of this down. Okay, I'm going to solve for this first, which gives me approximately 0.9695. So this tells me that B is sine of 0.9695, which is approximately 75.8 degrees. Okay, so we found that our sine was in the domain, and then we found angle A, which is 75.8 degrees. The question is there a second triangle? Okay, is there a second triangle? Okay, so remember that supplementary angles have the same sine value. So that means sine of, so I'm going to come back up here to the top. So that means that sine of 75.8 degrees is equal to sine of 180 minus 75.8 degrees. Okay, so if I let 75.8 degrees be B1, is there a B2? Okay, so is there a B2? So we let B2 be 180 degrees minus 75.8 degrees. So that gives me approximately 104.2 degrees. Okay, so 104.2 degrees has the same sine value as 75.8 degrees. Okay, what I need to check is that the angle that I was given, which is A, is angle A plus the second angle B2, is that less than 180 degrees? Okay, so if I add the angles together, they still have to be less than 180. Okay, so I have 104.2 plus, so this is B2, plus A, which is 61.4 degrees, which is going to give me 165.6 degrees. So yes, this is less than 180 degrees, so therefore there is a second triangle. Okay, so I'm going to let this left side represent triangle 1, where we have B1, and then I'll call this C1 and then side C1. Okay, so notice that AB and angle A are not going to get subscripts of 1 because that was information that was given to us. Okay, and then I'm going to draw a second triangle. Okay, so this triangle is obtuse. So this is B2. So we have B2 here. We're going to have A, side B. This is going to give me C2, and then side C2. Okay. So our angle B2 is 104 degrees, 104.2 degrees, and then B1 is 75.8 degrees. Okay, so both of these angles satisfy the value of sine, okay, that we solved for. So now we have two triangles to work with, so we need to solve for both triangles. Okay, we can easily solve for angle C for both triangles because we know two angles in each triangle. Okay, so C1 would be 180 degrees minus 61.4 degrees plus 75.8 degrees. Okay, so C1 is A plus B1. So that means that C1 is equal to 42.8 degrees. Okay, so then we need to solve for C2. So C2 is going to be 180 degrees minus A plus B2. Okay, so B2 is 104 degrees, 104.2 degrees. Okay, so this is A plus B2. Okay, and that is going to give me 14.4 degrees. Okay, so C1 is going to be 180 minus A plus B1. So that gave me this angle here. And then I solved for C2, which was A plus B2. So 61.4 degrees plus 104.2 degrees. And then 180 minus that. So that gave me 14.4 degrees. Okay, so the only measures that we are missing now are side C1 and side C2. Okay, so this is triangle 1, this is triangle 2. Okay, so let's find the sides. So to solve for the sides, we are going to use the law of sines. Okay, so for triangle 1, we have C1 over sine of C1 equals A over sine A. Okay, so that is going to give me C1, which we don't know. We're looking for that. Sine of angle C1. So angle C1 is 42.8 degrees. A is 35.5 degrees over sine of 61.4 degrees. Okay, so we multiply this out like we have been. So I get C1 is equal to 35.5 times sine of 42.8 degrees divided by sine of 61.4 degrees. So this is going to give me approximately 27.5 centimeters. Okay, so this tells me that C1 is 27.5 centimeters. Okay, so we have now solved triangle 1. We have all of the angle measures and then all of the measures of the sides of the triangle. Okay, so triangle 2, we need to find C2. Okay, so C2, we're going to do the same setup of C2 over sine of angle C2 is equal to A over sine A. Okay, so that's going to give me so I have C2 equals side C2. Let me take that off. This is not equals here. We're solving for C2, but so C2 over sine of angle C2 equals A over sine A. Okay. So now we have C2 equals this is angle C2 equals 14.4 degrees. So we have side C2 over sine of 14.4 degrees equals side A, which is 35.5, over sine of A, and A is 61.4 degrees, so sine of 61.4 degrees. Okay, so this gives me that C2 is equal to 35.5 times sine of 14.4 degrees over sine of 61.4 degrees. So this is approximately 10.1 centimeters. So that means that side C2 is 10.1 centimeters. Okay, let me just write this side here and here. Okay, so we have solved for all of the measures of these triangles. So these are the two possible triangles that satisfy the angles and the sides that we were given. Okay, so this is the ambiguous case of two triangles. Alright, so number of triangles satisfying the ambiguous case. So this is kind of a little outline of what we just went through, so we're going to do it again. Okay, so let sides A and B and angle A be given in triangle ABC. Okay, so that would be a side-side angle. The law of sines can be used to calculate the value of sine B. So 1, if applying the law of sines results in an equation having sine b greater than 1, then no triangle satisfies the given conditions. If sine b equals 1, then one triangle satisfies the given conditions and b equals 90 degrees. Okay, and then the third case. So if sine b is greater than 0 and less than 1, then either 1 or 2 triangles satisfy the given conditions. Okay, so in this case, we'll let, if sine b equals k, then we'll let b1 be sine inverse of k. So we'll let b1 be the first angle that's solved, and let that be the angle for the first triangle. Then we'll let b2 be the supplementary angle of b1. So b2 will be 180 degrees minus b1. Okay, so once you find b2, you then have to check, okay, is a plus b2 less than 180 degrees? So a was the angle that we were given in the equation, and then b2 is the supplementary angle that has the same sine value as b1. So we have to check if we add a and b2 together, are they still less than 180 degrees? Okay, because the measures of a triangle have to be less than or equal to, the measures of a triangle have to add up to 180 degrees. Okay, so if a plus b2 is less than 180 degrees, then a second triangle does exist. Okay, and then for that case, if there's two triangles, you will let b2 be b in the second triangle. So example 3. Solve triangle ABC given b equals 68.7 degrees, side b equals 25.4 inches, and side A equals 19.6 inches. Okay, so we have A, B, and C. Okay, and then this will be side A, side B, and side C. So we know angle B. Angle B is 68.7 degrees. We know side B is 25.4 inches. And side A is 19.6 inches. So notice again that we have side-side angle. Okay, so we want to solve for angle A. So A over sine A equals B over sine B. Okay, so this is going to give me 19.6 over sine of A equals 25.4 over sine of B, which is 68.7 degrees. Okay, alright, so we have 19.6 times sine of 68.7 equals 25.4 times sine of A. So this means that sine A equals 19.6 times sine of 68.7 over 25.4. Okay, so this is approximately 0.7189. Okay, so if I want to find angle A, I'm going to take the inverse. So A equals sine inverse of 0.7189, which is going to give me approximately 46 degrees. So we want to know, is there a second triangle? Okay, so we're going to see, is there a supplementary angle to 46 degrees that also satisfies this equation? So we're going to do 180 degrees minus 46 degrees, which gives me 134 degrees. Okay, then I need to check, is 134 degrees plus the angle that we were given, 68.7, less than 180? Okay, 68.7 degrees plus 134 degrees is equal to 202.7 degrees. So it is not less than 180. So because adding these two angles together is not less than 180 degrees, there is not a second triangle. Okay, so this tells us there is only one. There's only one triangle in this case. Okay, so from there we're going to solve just the one triangle. Okay, so we found that A was 46 degrees. So we have two angles, so we can find the third one. So C is equal to 180 minus 68.7 plus 46 degrees. So C is 65.3 degrees. Okay, so the last unknown measure that we have is side C. So we're going to use the law of sines to find side C. Okay, so we're going to use B over sine B equals C over sine C. Alright, so this is going to give me 25.4 over sine of 68.7 equals C, because we don't know what side C is, over sine of 65.3. Okay, so that means that side C is equal to 25.4 times sine of 65.3 degrees divided by sine of 68.7 degrees. So this is approximately 24.8 inches. Okay, so we have solved for all of the missing measures in our triangle, so this triangle is solved. Okay, last example, without using the law of sines, explain why no triangle ABC exists satisfying B equals 93 degrees, side B equals 42 centimeters, and then side C equals 48 centimeters. Okay, so if you notice, angle B is greater than 90 degrees. Okay, so that means that angle B is an obtuse angle. Okay, so if it is an obtuse angle, then it must be the largest angle in your triangle. Okay, so if it's an obtuse angle, it must be the largest angle in the triangle. Okay, which also means that side B must be the largest side. Okay, however, we are given that side C is greater than side B. Okay, this is not possible, so therefore no such triangle exists. Okay, if you were to go ahead and set up the equation using the law of sines, you would find that sine of angle C is greater than 1, okay, which is also not possible.